Okay, we've looked at the disk method when we rotate around the x-axis. What about if we rotate around the y-axis? So we'll have some function here where x is a function of y. You're not used to thinking of that. You're always used to thinking of y as a function of x. And now we're going to have x as a function of y. So this will be some function that'll pass the horizontal line test instead of the vertical line test. And then we're going to rotate that shape around the y-axis instead of the x-axis. Then our volume will be exactly like we did rotating around the x-axis. The cross-sectional area, dy, the integral from start to end. So this is going to be best explained using a picture. So I have some function here, x, that means x, is a function of y, 4 minus y squared. So you plug in a y, it spits out your x value. So here, let's look. Let's plug in y equals 4. Square root of 0 is 0. I get x equals 0. Let's plug in y equals 2. No, that wouldn't work. Plug in y equals 0. So y equals 0 is the x-axis. I get square root of 4. I get 2. You plug in a y value, it spits out an x value. We're going to take this curve and we're going to rotate it around the y-axis. So we get a shape that looks like this. And then we're going to use the disk method. We're going to build up a bunch of disks vertically. We're going to stack disks on top of each other. If you're rotating around the x-axis, you're going to have disks whose axis is the x-axis. Whoever you're rotating around, that's the way your disks go. We're rotating around the y-axis, so we're going to stack up disks vertically, a bunch of disks that look like this to fill in this void. Then this volume will be the area of some, we pick some random y value. Like here, we've picked some random y value. What is the cross-sectional area of this disk? Well, that's a circle. What's the area of a circle? Pi r squared. What's r? The function value. Like remember, here's our formula. That's just r squared, pi r squared. That's all that is. So we're going to have pi r squared evaluated from start to end. What were our start and end? From 0 to 4. So the definite integral from 0 to 4, pi r squared. Square root of junk squared is just junk. We just do the integral. You can check these details on your own. We're evaluating from 0 to 4. We get 8 pi cubic units.